Hello everyone. So this is Ronit from CodageAider's team, and so today's session is about recent coding challenge. So this is actually was part of the Toptal interview. If you have come across the company called Toptal, so that actually hires people for remote work and sometimes some people for also client-based work. It's a very popular company, and this is the question that was recently asked in the round two of this uh, particular company for the position of software development engineer. And will go over this question and I will provide a solution in Java, although the approach that I will be telling will be quite similar and can be converted easily to other programming languages. If you have any questions about it, you can just paste it in the chat. And in case you have any other queries, you can paste in the chat or also even after this session is over, I will share my contact details. You can ask anything on that. And in case you want, I'm planning to conduct these type of sessions every week and preferably every Sunday and at the same time that we are doing it nowadays. So last week also I had a session on the Sunday at the same time. And if you have any special questions regarding any company's interview process, whether it's online coding assessment, object-oriented design, system design, something you want me to discuss in the next session, you can message me directly and I will try to cover it in one of the upcoming sessions. So you can go over this question and just take few minutes to think over how you can solve this. So Toptal is little bit challenging because generally they give very less time. This is like a ask in the virtual live interview and they generally give only 15 minutes to solve this problem. Although the question is not tough, but solving it in 15 minutes if you have not seen this kind of problem can be difficult. So just take few minutes and I will then explain you how to solve it. And if you have any ideas, you can share in the chat. I have disabled everyone so that not everyone can talk because it makes things easier, but you can all text me in the chat message. So if you have any idea about how to go about solving this problem, you can message me in the chat box. So if you've gone over this question, this is talking about XML tags. And basically, the easier part of this question is that there is only one type of tag, which is this app tag, and there is a corresponding closing tag that is usually there in an XML. And what this question asks is, Like given an XML which only consists of the opening tag and the closing tag with this name app, we would need to count how many parentheses are improper. So for example, if you see this tag, this is a seems a proper tag because this particular app matches with this, and then this closing tag matches with this opening tag matches with this, and this closing tag matches with this. And if you see the question, it's just little bit verbose, but it's basically boils down to counting the number of XML tags that are broken. So that's what this question says. If the logger got broken and it's sometimes missing the correct information in the log, your task is to write a function that will take the broken log and output how many tags were missing from the file. Or it actually has posed in a different way. How you have to count how many missing tags are there. So if you see this particular string, so if you see this first app, it's an opening tag. The second one is a closing tag. So they match. And then there is a closing tag, and then there is a closing tag. So to make this a complete, well-formed XML, we need two opening tags. And unless we insert two opening tags here right in the between, this XML will not become proper. Or in other words, there are two closing tags which are not in the correct place or which make the XML malformed. So this information, this interview is actually for a senior position for a backend developer. And even for front-end developer, sometimes they can ask to write this kind of code. Uh, it's mostly for people who code in backend languages like Java, Python, or any other backend language. But if you are just purely JavaScript or based developer or front-end developer, then they might not ask you this kind of question. The chances are very less. Yeah, so this was one of the question asked by one of the person in the chat. And if you have any question, feel free to keep on messaging. And initially, I just want to make sure that you understand what's going on here. Yeah, so if you're a full stack developer that use Node.js, it's possible that they can ask you to, code, ask this kind of code in the Toptal interview. In the upcoming session, I will also share some questions for front end and Node.js, which were asked in the latest interviews, and maybe that will be more directly related to your experience. So although here in this particular example, I will be coding in Java, but the important thing is not language, but the idea behind solving this problem. So if you see the second one, so the initial thing I want to make sure that you understand this opening app matches with the closing app, then this opening app matches with the closing app. So this parenthesis, this XML string is balanced. This is a correct XML. So there is nothing wrong with XML, so there are zero missing tags. And if you see this, there is a close opening app, then there is a closing app, then there is an opening, then there is opening app. So we need two closing app tags to make it well-formed XML. So two closing app tags are missing. So the output is the number of tags that were missing in the XML, such that if you insert those tags, the XML becomes a well-formed XML. Similarly, in this, there is a closing tag. To make it a proper XML tag, we need to insert an open tag here. That's one. Then there are two open XML tags. To match this and to close this properly to open XML tags, we need to insert two closed XML tags. So like slash app and slash app two times. So therefore, there are three tags that are missing. I will explain it in more detail by writing an explanation for it here. So I will just I've already prepared some code which actually write down this particular example. So I will just paste this example here. So this is nothing but exactly what you see here in the test cases. Open app, closing app, closing app, closing app. The answer should be two. and I have just inserted the same thing here. So I will explain it in a little bit more detail. So let's take this string for example. Now this is an not unbalanced string because this particular front slash app closing tag doesn't match with any. There should have been an opening XML tag, but I can add an opening XML tag and match it. Now this matches. This is well formed. Now there is this single hanging closing tags, and I can make it well balanced by adding one more opening tag. So I need to add two XML tags. It doesn't matter whether they're open or close XML tags. All we need is the count of XML tag that we need to add to make this string XML string a well balanced XML. So there was the answer is two. Now let's look at this one. So this starts an XML that starts with a closing tag. That cannot be well formed XML unless there is a corresponding opening tag. So if there is a closing tag, there has to be a corresponding opening tag to make it well balanced. And if there is an opening tag, there has to be a closing tag to make it well balanced. So I need to add three tags to make this XML well balanced. So overall, what we are given in a string is a list of tags, and some are open and some are closed. And every open tag, there must be a closing tag. And for closing tag, and the closing tag must occur after that opening tag. Opening tag. And for every closing tag, there must be a open tag before it. Because the only way an XML is well formed is that each open tag matches with a closing tag and each closing tag matches with an open tag. And if that doesn't hold, that XML will not be balanced. So for each open tag, there must be a closing open tag, closing tag, and for each closing tag, there must be an open tag. Now, the question actually asks us, given such an XML, how many tags are missing from it? So if you have any ideas, you can message in the chat box. How do you think you can go about solving this? Yeah, but if you see in the last case, this particular case, that approach will not work because there is one closing tag and there are two opening tags. Like what you are trying to do is subtract the number of closing tag from opening tag. Is that what you want to do? Okay. Okay. So this particular thing occurred one time and this occurred two times. Yeah, that's correct. So if the number is not equal, then certainly that string is unbalanced, right? But still, we that will not tell us how many tags we need to insert that will make it balanced. Because we can also have a string like this. Like in this case, This is unbalanced. And yeah, the order also matters. And the closed count is 1. And so this approach will not work. So actually what we can do is, I will start, uh, so I think the one way to simplify this problem is to get rid of, because this is a string, and if we are actually trying to code it, it will be difficult to actually detect this kind of tags. We need to detect this kind of tag. When do we encounter closing tag and when do we encounter opening tags? So one easier way is to actually convert this opening tags to a open brace and a closing tag to a closing brace. If we do that, then this type of string simplifies the problem. This type of string becomes like this. This is a closing, this is a closing. So this is like a parenthesis. And similarly, if we have this, there's an open, then there's a close, then there is open, then there is a close. So if you see, this is a balanced parenthesis. So this becomes, the problems become very similar to the balanced parenthesis problem, which you might have seen at several places. So what I'm doing here is replacing the opening tag with the open brace and closing tag with the closing brace. Because all we need to do is match the opening and closing tags, and that can be transformed to match the opening brace and closing brace. So this can make the thing a little bit easier. So now if you see, the only tags, now if you see in this particular string, the parenthesis, now with this closing tag there is a matching opening tag, there is a matching closing tag. Now there are few open tags which are which don't have a matching closing tag. So the third char is this doesn't have a matching open tag, open parenthesis. The reason for transforming it to this is because it makes it easier to parse the string. Otherwise, we will have to all the times look at when does the tag start and match this less than. And there are very easy way in all the programming languages to do it. And the fourth char is this doesn't have a closing tag. So there are two tags which doesn't have the matching tag. So the answer is 2. So if you follow this kind of approach, then that means we have to count the open parentheses that are unmatched and closed parentheses that are unmatched. I think that is one of the key points here. So we have to count the open parentheses that are unmatched. So here, if you see these, there are two open parentheses that doesn't have a matching close one. And if you see here, there are no open parentheses that are unmatched. And here there are two open parentheses that are unmatched. Sorry, here there are two closed parentheses which doesn't have a match. So in this case, the answer is 2 because there are two closing parentheses which don't have a corresponding open one. And in this case, the answer is 2 because there are two open parentheses which doesn't have a closing parenthesis. So actually, if you see, the answer is nothing but actually unmatched open plus unmatched close. Now, one way to, so I will explain the solution and write a code, and then we can dig deeper into it if further explanation is required. So there are several ways to solve it. One simple way is to use a stack data structure. This is similar to what actually one does when we want to determine if a parenthesis is balanced or not. So, like suppose this is the string, and what I do is I maintain two stack. One is the open stack, and one is the closed stack. And initially, when I scan this string, so this stack I'm maintaining just from left to right, just for the ease of writing. So initially, I encounter this string, I just append it, and then I encounter a closing stack, closing parenthesis. And when I encounter a closing parenthesis, what I do is I pop the if there is a matching opening parenthesis, or if there is something in the stack, open stack, then this will get matched with this, and we pop both of this out. Now next we encounter again a closing tag, but there is nothing in the open tag, so we cannot pop this. Then again we encounter the closing tag, and there is nothing in the open in this stack, open stack, which we can match with. In the end, what we have is this each stack, the stack O will be left with unmatched open parenthesis, and stack closed will be left with unmatched closed parenthesis. So we just need to check the count of this, just sum the count of this. This is similar to this one. If you understood what this, how we came to this particular thing. So this is nothing but the size of O and the size of closed stack, which in this case is equal to 2. I will run it over one more example, and then we'll start writing code, and then we can discuss it further. So our first idea is to actually convert it into parenthesis approach. Now we have this particular string. Now we have an opening stack and we have a closing stack. So initially we encounter a closing stack and we cannot pop it out because there is nothing matching in the opening stack. So each time we actually insert a closing parenthesis in C stack, we check if there is a open parenthesis available in the opening stack. If there is, we pop both of them because that means both of them matches. They match with each other and they form a pair. And the only time when we insert a closing tag in the C stack and the O stack is empty, and then there is no match possible, and that means that particular closing parenthesis is one of the unmatched parentheses, so it will stay here. But so the popping is only done when there is a closing tag, and it's done only when there is a matching opening tag. So we have a closing tag, and now we have a open parenthesis. Then we again have an open parenthesis. So when we actually inserting open parenthesis, then we don't need to pop anything because we only pop when we encounter a closing parenthesis because the closing parenthesis will match with something earlier. So this is what our stack will look like. And if you see the size of this is 3. And that's what the expected output. And this is the exact question from the round 2 virtual live interview of Toptal. And if you see the answer is 3. So I will write a code for this using stack, and then I will also explain another simpler approach which can be done without stack. But using stack, it's sometimes easier to understand this problem because this can be easily converted to this parenthesis type problem, and the matching parenthesis, which is a very standard problem. This is like a modification of that. It's done using stacks. So I will just write a tester main function. This is the function which we need to implement. So I'm giving the variables here. I'm giving appropriate names because this is, if you see in the question, these are actually the logs. So it's generally a good programming style to actually give a proper this kind of naming convention, which actually matches the description. And these are just the sample test cases I'm writing. So if the code is correct, this should answer true for all this because I'm matching them with the correct output. So first idea is to actually convert this log to parentheses. And we can do the code here, but it's generally a good idea to break this into a different function. So to convert this to parentheses, basically this style, all we need to do is replace all this open tags with this particular open parenthesis and closing tag with this particular closing parenthesis. Because after this, we can loop easily using a for loop. So what we can do, we can initially Java provides this function replace all. just to make sure, just to test out our function that this is outputting correct values, we'll just run this function. So when we write the complete code, this should actually all convert to true. That means all the test is passed. So if you see, this converted this particular to open, close, 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 and this to closed, open, open. So that's all we're doing here. We're converting it to parentheses. Then the main part starts where we can actually use two stacks. One to track open parenthesis and another one to track closed parenthesis. Now we can easily loop over this log with parenthesis, convert it to char array. We couldn't have done this with the original log string because that would require parsing XML. But once we convert it to this parenthesis, we can easily do this logic. If it's an opening tag, then we simply insert it into the stack. If it's a closing character, then there is a possibility that this closing matches with something in the open and it will have a match if it's not empty, if the open stack is not empty. If it's not empty, then we can just that means this particular thing matches something in the open stack and then we can pop from the open stack. Else there is no matching open tag, so that means that this particular closing and doesn't match with anything, so we just simply insert it into the closing tag. Sorry, so if it's not empty, then we pop the open stack, and if it's empty, then we just push it. And in the end, the same logic what we actually wrote here. So all this code and everything will be there on my GitHub repository, and I will also post this as a YouTube video, so you don't need to save anything. So here we do open stack size and close stack size. So let's run the program and see if all the test is passed. Yeah, so true to true, this means that our count missing tag on this input actually returned 2, on this input it returns 0, on this input it returns 2, and at this input it returns 3. So if you have any queries related to this approach, you can just message in the chat or you can talk about it. So I will just, uh, if there is anything that is not understood in this, and I will also show an approach which doesn't use stack. We can also do it without using any special data structure called stack. So I'll just write one more function and explain the approach behind this. And we will also test out this function, which is can be more simpler. So it's sometimes natural if you have worked with stacks, it's sometimes natural to think in this way. And at other times it's natural to think in the approach that I'm gonna tell now. So if you see in all this thing that we have discussed, all we care about is how many open parentheses, how many unmatched open parentheses are there, and how many unmatched closed parentheses are there. That's what we need to count. So all we need to count is actually one thing is unmatched. I'm just converting this to a variable name, unmatched open parentheses and unmatched closed parenthesis. These are the two things that we need to count, and the answer is nothing but the sum of these two. Now, instead of using stack, we can also use these variables, because what happens is when we encounter an opening parenthesis, at that time it's unmatched. And when we encounter a closing parenthesis, if you see what we do, if there is something, if there is a corresponding open parenthesis, we can match with it, and we are what we are doing is we are popping it out. Popping the thing out for it. So if there is a closing parenthesis encountered, then the unmatched open parenthesis decrements by one. So I will just give an example how it works in this particular case. So initially we encounter the open parenthesis and the O is 1, and then we encounter a closed parenthesis. And when we encounter a closed parenthesis, what we do, we see if there is an open parenthesis, the number of open parentheses unmatched till now is 1. But since now we encountered a closed parenthesis, this will match with this particular one, so we decrement it. The idea is if there is a open parenthesis, if there is a closed parenthesis, and O is not equal to 0, that means there are some open parentheses that are present. Then we can just decrement O by 1, and if O is equal to 0, that means this particular closing parenthesis doesn't have a matching open parenthesis, so we can just increment the C by 1. So let's execute it over this example again from the beginning. So initially we have O is equal to 1, then we encounter a closing parenthesis. So we'll start with this is the initial case. So initially when we encounter an opening parenthesis and O becomes 1, C becomes 0. We only decrement when we actually have a closing parenthesis. So now we encounter a closing parenthesis, and since there is a something in the open parenthesis, what we can do, we just decrement it by 1, which is 0, closing parenthesis equal to 0. Now we have one more closing parenthesis. We cannot decrement, we have to increment this time because there is nothing in no unmatched open parenthesis left. So there is no match for this particular procedure. Then we encounter one more closing parenthesis. And since the opening one is 0, so it's 2, and the answer is O plus C, which is equal to 2. And that's what the answer is for this particular case. So this approach actually just require maintaining two variables, and the initial part remains same. So when encounter an open parenthesis, that means the unmatched open parenthesis count increases, because to have a match we need a closed parenthesis after this. Now that else, that means we have a closing parenthesis, and if we have a closing parenthesis and number of unmatched parentheses is greater than 0, then we can match that closing parenthesis with this particular open parenthesis, and the number of unmatched open parentheses decrements by 1. But if there is no open parenthesis to match with this, then this particular closed parenthesis will not have anything else to match it, and so we increment this. This is a more simpler way, and here if you see I have converted this to the second function, and if our code is correct, it should output true because it should output the same value for all these four test cases. This is output true for all the cases. So the approach is same, but this is like more simpler. Just uses two variables where one tracks the number of open parentheses and another tracks the number of closed parentheses. And if we found a closed parenthesis, we see if we have an open parenthesis with us because we are maintaining the number of open parentheses we have till now, which are not matched. So we can match that open parenthesis with this currently encountered closed parenthesis and decrement the count. So the O and C variable, they actually the unmatched open parenthesis and the unmatched closed parenthesis variable, the value, they remain updated all the time. If we encounter an open parenthesis, that will an open parenthesis is always an unmatched open parenthesis because it will only get matched when we encounter an closed parenthesis later. And so we just need to maintain these two variable counts. And in the end, the values will left will be those open parentheses which we didn't find a closing parenthesis match, and those closing parentheses which we didn't find an open parenthesis match. And we can sum them up and return the answer. This is similar to this approach. There is nothing much difference. Only thing is this is more simpler if you are not used to using this Java stack and other data structures. So I will post this thing into the GitHub repository, and I will also post this on my YouTube channel. You can subscribe to this YouTube channel so that you will have access to the code and this explanation also. And in case you have any doubts or anything, you can talk right now or even message in the Google Meet chat, or even later you can contact me on any of these three boards, and or even just put a comment on any of my YouTube videos and I will respond to you. And if you want to discuss any other problem that you encounter in the interview which you are not able to solve or find solution, I can help you with that.